don't think anybody's in yet.
Uh,
Three people.
Actually, I think it's two.
Two.
Actually, it's one. Because I think they count me as one.
It's Anna and Shreya.
Oh, yeah?
Yeah. Anna commented.
Hi, Anna. Hello, Shreya.
There was three.
Oh, there's another one. Oh, that's Andrea. Because I think it counts me. Well, somebody has
Ask a
internet.
Question? Yeah, Anna asked a question.
Oh.
On the live chat.
19. Somebody else sent me this is off. Dang it. 12 and 13, Marissa needs.
Oh, hey, Coach Ryder.
Hey.
Didn't you say you'd give us like worksheets or whatever, or like note sheets?
Oh, yeah, I got y'all. Yeah, I got y'all.
Hand those to us. What did you give us on Friday?
I didn't give y'all anything on Friday. I don't
Yeah, he
think.
didn't give us.
Yeah, we had.
Yes, I do have those for you.
Give them to
Hey,
us.
how's your
You gave us
COVID
some
shot going?
It hurt,
He's supposed to-
but I felt okay. It's still a little sore. No, it's fine.
Nothing else?
When did you get your second one?
12?
Was it the Pfizer or the Moderna?
Either.
Nice. I'm jealous.
Are you?
Or no, I'm so jealous, honestly.
No, I didn't have any side effects or anything. I kept Tylenol in it.
That's good.
They should have sent it out.
Did you have it done at Northwest?
But they did it at West for us
Oh,
teachers.
that's fun.
That's how I knew I was getting old, because they only had so many doses, and so they went off your age. And I got it.
Were they doing the whole district? or just one?
The whole district, the whole district.
Mr. McElroy was so excited to get
You,
class.
oh my gosh, he was so high. I don't need one.
He missed class, he was like,
You?
I'm
He's like,
canceling.
I missed your Halloween.
Yeah, he's like, I'm
Saturday."
canceling the Google Meet today, I'm getting my shot. He's like, you go.
Oh, I heard, I can find out.
You want them?
Gotcha.
Good night.
I'm like calculating, I'm finding like products that I can sell,
Yes.
and I'm calculating the multiple percentage for them, and I'm like multiplying it by 2,900%. Because I'm buying next house for like 50 cents, and selling it for $15.
I don't know, it's not like who best represents, I don't know who voted on it, I guess.
How, is that how you got nominated?
That's what my email said, it was like a group
It
of
was,
teachers.
some of them were weird, I'm like, this person was not weird.
I know.
Oh,
Why was
I-
Tyler Hoggett in most videos?
He was. I'm both I totally. Oh, that's funny.
How are you?
Okay.
voting?
Do I dare ask who
You have to log into now if you want.
Nader Bra is, or?
like for the people that I didn't like again. Oh, that's fun.
You think
Or is that, maybe I make it public and somebody just jumps on?
Is that Kelvin?
Who is it?
That's Carson.
Oh,
I
Carson.
love that man so much.
Yeah.
I told Bill that when he
Sometimes I
first
wonder if
said
his elevator goes all the way up.
It does.
It doesn't?
I don't think it does.
Okay. Oh, that makes me feel better.
No, I don't think so.
All righty, if you have not worked these yet, now would be a good time, or just at least follow along. I've lost all my stuff now. This is number 12. Okay, that's the first one. Oops, I may have hit the wrong one.
Yeah, sure, that was no.
So number, I gotta do something bugging the heck out of me. I gotta fix it.
Do I have any pens?
Sorry.
Do I have any pens?
He said I made that account name without
That
a
one's
pen.
so sad. Just open it up, you're all done. But if, depending on which pen you take, you have to be careful. Sorry, that's blind my hands.
Okay.
I have these ones as well that are
I put him in on.
I need to make a pencil.
You're right.
Maybe I should just carry.
I got.
Probably got some better sleep.
You want lunch?
Ah, that's what I needed.
No, I got you. The med can go there, do that.
Except I can't see the question again.
You got the snap stuff.
Here it goes. No, how do I get up there to the question? I don't know how to get up to the question. Oh, here it is. Finally. Sorry, here we go. So this is one of the questions we were asked, or one of my students, I think it was Ms. Baumover. 2016, a survey of 1480 randomly selected U.S. adults found that 55% of the respondents agree with the following statement. Organic produce is better for health than conventionally grown produce. Construct and interpret a 99% confidence interval for those who think that organic. So go through and construct it. I probably can come close to guessing which one it is just without even constructing it. We are 99% confident that the interval from here to here captures the true proportion of adults who agree with it. So that one could be correct. It just depends on the numbers, but that statement is okay. We are 99% confident that the interval from here to here captures the true proportion of U.S. adults who agree with the statement. That one could be correct. The only thing that's different is here is the numbers. We are 99% confident that the interval from here to here captures the proportion. This one is not correct because it does not say the population proportion or the true proportion. So this one automatically is not correct. We are 99% confident that the interval from here to here captures the true proportion. That one could be correct. We are 99% confident the interval from here to here captures the proportion. That one is not correct. Fair enough with that? So I'm just going to kind of cheat, and I look and I see that two of these, no, I'm sorry. So I need to actually do it, I guess. So it's, let's see, 1480, and it was 55%. So I'll go to my calculator. I hope I didn't stop my thing when I showed y'all a calculator the other day. One class I did, I said before I did my calculator. And we will wait for that to open up, and we will go to stat test and go to 1 prop z int. Uh-oh, went too high. Whoops, I went over one, that's why I did it. 1 proportion z interval. That's the method that we need to use, and that's why we just go ahead and do it right there. 1 prop z int. I'm okay with you abbreviating it like that. 1 prop z int. X is whatever 55% of, I didn't say this, whatever 55% of 1480. So 814, that has to be the number of successes out of the 1480. And it was it 99%?
Yes.
0.99. 9. Calculate. And there's my two numbers, 0.516 and 0.583. 516,583. Looks like it's that one. Y'all okay with that? Okay, go check the answer. Woohoo! Next question. Number 13. Does the 99% confidence interval provide convincing evidence that the majority, okay, so I didn't talk anything about this kind of stuff. So let's kind of talk a little bit about that today. It says a survey of this 55% of respondents saw following statement: organic is better. 99% of the true portion organic produce the convention. So there's the freaking interval. Does the 99% confidence interval provide convincing evidence that the majority? So this is, you have to kind of read into this a little bit. What would the majority be? 50%? Right? Majority would be 50%. Does it provide convincing evidence that a majority of all U.S. adults think that organic is 50% in this interval? It's not, right? It's above it. I'm sorry, 50% is below it. So they think the majority would be 50%. We're above 50%. So we do think that because this interval is above 50%, because 50% is not in that interval, we do think that there's enough evidence to think that the majority is higher. Follow that? Let me kind of restate all that again. Because this interval, this entire interval is above 50%. Now, if 50% was in it, we don't think so. Even if it was barely down here. But because this entire interval is above 50%, we do think we have enough evidence that the majority. I hope that kind of makes sense. So does a 99% confidence interval provide convincing evidence that a majority, I wish they would have put 50% in there, we don't have to read into that, but think that organic is better. We are 99% confident that the interval from here to here captures the true proportion. Who would agree? Because we are not 100% certain? No. I don't know what that has anything to do with anything. We are 99% confidence interval that the true proportion organic produces. This provides no evidence. No, I think it does provide evidence because it's above it. Even though the value of confidence interval are all greater than 0.5, this might not occur again in different samples. There's not enough evidence. I don't think I like that one. Yes, all plausible values in the interval are greater than 0.5, which provides convincing evidence that the majority of US think that organic. I kind of like that one. Let's look at this. Oh, no. So I think I like that one.
So,
I know them all.
Oh,
oh yeah.
what is that?
Lawnmower?
What's that long? Yeah.
My dad likes the shopping cart.
Oh, yeah.
Or I'll do the motorcycle.
Oh, yeah. Oh, I don't know that one. Oh, I thought I did know them all.
No, I'll show
You
you.
demonstrate.
Yes,
He's
and,
about like 49 right now, so like this.
It's really good.
He likes that one.
My dad likes the.
I like to churn the
light
butter.
electric guitar.
Oh, yeah.
Cute.
See, the bad part is, like, I'm the age of all your parents now, pretty much. So now that y'all found that out, right? Okay. Good. I hope. Let's see. I actually can do this now. This is Carson, the accountant when I was 10. Huh? Thanks, Carson. Figuring that out. 19. Newspaper reported an SRS of 100 residents in a large city for their opinion about the mayor's performance. Oh, not that mayor. Whatever. Using a result from sample, the confidence interval for the proportion is from here to here. What is the value of C? Ooh. Ooh. This is tough. Ooh. So you can do this one of two ways. Hunt and guess until you get this interval, which might be the easiest thing to do. Hunt and guess with this calculator because you know the sample size was 100 and you know P hat has to be right in the middle of that value. So that's a possibility of doing it. The other way to do this is to plug and chug into your formula and you have to solve. Uh-oh, I just erased those.
It was
What is this?
15 was the last one.
Okay, thank you. So the confidence interval would be P hat, which is whatever is exactly between 0.565 and 0.695, which would be 0.6. 565 and 695. 565. 0.695, 0.63. P hat, 0.63 plus, I'm just going to do the plus. You can do the plus or the minus. This z-score is what we don't know. Fair? That's what we don't know. That's what we need to find. Square root 0.63, 0.3, 100. And when I add it, I should get, oh sweet. Should get 0.695. And we just solve that algebraically. And then you have to still do inverse norm to figure out what the percentage was, because that's going to give you the z-score. Actually, you don't do inverse norm, you'll do normal CDF from this value negative to this value positive, and that will give you the percentage. I think it's easier to plug and chug in your calculator and just keep guessing. In fact, if you're really a calculator nerd, which I am, 95, 99, 82, 90. I'm just trying this for the very first time. Clear, stat, edit, stat, memory, clear all lists, 4, enter, stat, edit, 86. 95, I don't know if this is gonna work or not. They'll let me play. No, it won't work. No, it won't work. Oh, wait, it might. L1. Oh. Okay, it won't work. Never mind. Sorry, I was playing. I was trying to make a nice little list where it plugged them all in at one time and you could see the values, but it didn't work. So, all that to say, we would go stat, test, alpha A, and we would just do 86. No, that's the level. What was this, 0.63? 63 out of 100, because that's what P hat was. And then you just keep changing that to one of those until you get the values. Fair enough, you'll kind of follow that. Or use this formula, which makes it, this is not that easy, but it's not that bad either. Because you'll subtract this to the other side. You'll divide by this. That will give you the z-score. And then you just have to do normal CDF from the negative z-score to the positive z-score. And that will be level. Good question. One that was not covered in class, so I could easily see why you would have a question about that. Very common AP type question. Very common AP question. 15 was the other one. How large of a sample is required at most 0.03 with a 99% confidence? So this is where we'll have to do this formula also. Let me get my other marker. So we know the margin of error is equal to the z-score, square root of p hat, 1 minus p hat over n. Trying to find. Margin of error is 0.03. 99%, I think, is 2.54. I think it's 2.54. Let me check. Inverse 0.99. I can cheat because I have a center. Oh no, 2.58. 2.58. Square root, and they want me to use the conservative 0.5 and n, and we just got to solve that for n. So divide this side by 2.58, then square it, and then take 0.25 and divide it by that. So 0.25 divided by 0.03 divided by 2.58 squared, 1849. Came up exactly, holy cow. So 1849 is what I got. 1849, it doesn't even look like I can get there. So my guess is 1844. That's what we got to do. I don't know, I got 1849. I would have thought it had to be at least 1849 or bigger, but maybe it had to do with a rounding issue, I guess. All right, did y'all have any questions? Nothing at all, we're okay, we got those now, we're good? This is, some of these problems are gonna be a little bit more difficult than just actually laying it out. Laying it out was the easy part, doing the entire 4-step process. Okay, and doing the entire 4-step process. Let's see how we're here. Carson, he still hadn't said anything. I still got 4 of us on there. Woohoo! Girl basketball, my drive. Stats, mine. Chapters 8, 3. Wednesday today, tomorrow is a B day, Friday is a B day, so I won't have anything to do with you guys, okay? I'll still be online for my stats kids, for my pre-cal kids. I can get online with you guys during 5th hour if you want to. And if you don't want to, don't worry about it. But I'll put that on a, what do you call it, the stream. I'll just state that out there. Because that's 5th hour is my virtual class. So it's a virtual stats class. So if you can get on there, and if you can't get on there then, but you still would like to get on that sometime Friday, just let me know. Because I have to be up here anyway, and I have nothing better to do than to help you guys. I do not have an advisory class, so I'm free that entire time also. So I'll be free pretty much all day. My class is 0B, and I'm free anytime after that. So if you need to get online for anything else on Friday, just let me know. 8.3, here we go. This won't take very long. I will not rush through it, but it will not take very long. Estimating a difference in proportion. So the only thing difference between this lesson and 8.2 is we're going to be having 2 different samples. We'll have 2 different samples. Hopefully they will be 2 independent samples. But again, we will talk about that as we go. Determine whether the conditions are met for constructing a confidence interval about the difference between 2 proportions. So there's conditions for it. They're very, very, very similar to our previous conditions. And then construct and interpret a confidence interval of the difference. So that's pretty much it. Conditions for constructing a confidence interval about difference in proportion. So picture this, guys, right? I'm going to have 2 different samples, right? I'm going to have a sample of females and a sample of males, whatever it might be. But I got 2 different samples. So if I have 2 different samples, I'm going to have 2 random samples. Hopefully that's the first one. And not only can they be random, but they have to be independent. So that's our first condition we want to check. We want to check to make sure that we have 2 independent random samples. More times than not, it's going to state that explicitly in the problem. Sometimes it has to just be assumed that it's independent. We'll take a sample from this school and a sample from Rogers. This school has no bearing on that school, therefore there should be independent samples. Okay, talk to me.
If you were to take like a sample from like us and labs, would those still be independent?
I still consider that independent. Yep. If I took a sample from this group and another class, I'd almost consider that independent. I could probably, depending on what the question was, right? So a lot of that depends on the question. Do you like the internet? I wouldn't think that would be, we have too much in common there. We have an age group. Kind of see that? But for the most part, it's going to state it in the problem. Okay, so now we have 2 independent random samples. Not only do both samples have to be independent, both samples need to be less than 10% of the population, both of them. So this sample over here of males needs to be less than 10% of the population, and this sample over here of females needs to be less than 10% of the population. So hopefully we can just see what we're doing here, but we're just escalating this. Instead of just doing one of these, we have to do 2 of these. And so all the conditions for one have to be met for all the conditions of the other one. So sampling without replacement, that's the key. That is the key. This is going to actually come up in this particular lesson today about with replacement, without replacement. When sampling without replacement, we need the 10% condition. All right, and then the other one we have to have is the large counts, and both groups have to be large counts. So this group over here has to be approximately normally distributed because n times p and n times 1 minus p are bigger than or equal to 10. And this group over here has to fit the large counts condition, which means that n times p and n times 1 minus p have to be bigger than 10 also. So all we've done from 8.2 is escalate it to where we have 2 independent samples. We have 2 independent samples, and so we have to do all 3 things for each one of those. That one has to be random, that one has to be less than 10%, and that one has to be approximately normal by the large counts. This one has to be random, this one has to be less than 10%, and this one has to be approximately normal because of the large counts. All right. Everybody okay with the conditions? Some of you guys are still writing them. I will slow down. Okay. All right, here we go. Problem. A Harris Interactive Survey asked independent random samples of adults from the United States and Germany about the importance of brand names when buying clothes. Of the 2309 adults surveyed, 26 said brand names were important compared to 22 of the 1058 German. Stop right there. I'm looking at, okay, got a lot of stuff going on, but I have 2 samples, one from the US and one from Germany. So I recognize right now I got 2 samples. And I actually see some percentage symbols. So not only do I have 2 random samples, I have 2 samples that are proportions. That, of course, will always happen in this section, but next or a couple chapters later, it won't. We have 2309 adults from the US, and we have 1058 adults from Germany. Let P sub U be the true proportion of all adults who think that the brand names are important when buying clothes, and P sub G be all the German adults who think they're important. Check if the conditions for calculating the confidence interval for P sub U equals P sub G. So here's what I want to make sure that you guys understand first. If I want to prove or show that P sub U equals P sub G, we also need to know that P sub U minus P sub G equals 0. Because if I put that over there, then we can have that. So each one of those 2 are the same statements. So just make sure you kind of understand that. From last chapter, we know all we need to know about the sampling distribution of one proportion minus another proportion. But we're not asked anything of that. All we're asked for is the conditions. So the first conditions, do we have 2 independent random samples? Yes, and that's what we need to state. We have 2 independent random samples, one from US, and you might actually say there's 2309 from the US, and we have 1058 from Germany. Let's see what this says. Independent random samples, 2309 US adults and 1058 German adults. So y'all kind of see they didn't use the word independent, but we just have to assume, yeah, those are independent samples. What happens in the US doesn't have any effect at all on the things in Germany. All right. When we sample a US person, did we put them back into the population and sample them again? I don't think so. I don't think that was with replacement. So I think we need to check the 10% rule. So I'm going to really guess that 2309 is less than 10% of all US adults. And my bet is that 1058 is less than 10% of all German. There we go. Again, recognize my first question, right? Once we sampled somebody, did we put them back into the population? No, we sampled them and took them out. I'm sorry, we put them back in. That was with replacement. When it's with replacement, we got to check the 10%. And then the other one we have to check is the large counts. And the large counts say that we need at least n times p, and n times 1 minus p bigger than 10, and then we have to do it over here for the Germans. The Germans ain't got nothing to do with it. Anybody know that movie? I cleaned it up a whole lot, but it's probably the funniest movie ever. I can't say that, but it's funny.
What is it?
The Germans ain't got nothing to do with it. Smokey and the Bandit. And Jackie Gleason says that, except he throws about 6 other words in there that I can't say. One of the stories, I was interviews I saw with Jackie Gleason, they asked him about that, how he was, we call it, you don't interview for a job, what do you do when an actor applies for a job or screenplay? Audition, thank you, audition, that was the word I was looking for, thank you. That was a tough word I was looking for. When he was auditioning for that, they asked him, he said, what are you going to do different than everybody else? He says, I'm going to cuss the entire time. And he did. He did. Sometimes cussing makes it funnier. It does. And he did. Anyway, here's n times p and n times 1 minus p. Here's n times p and n times 1 minus p. These are sub u's, these are sub g's. I don't really care that you do all that stuff. Just make sure you separate it out into 2 separate groups. This number is 600. This number is 1709. This number is 233. And this number is 825. All 4 of those are a whole lot bigger than 10. Of course, we don't care as long as they're just bigger than 10. I'm having to verify because all the years I've done this, I've always said, so the sampling distribution is approximately normal. And I haven't seen this book do that yet, but I really believe that's in the rubric. We're proving this so that we can say that it's approximately normally distributed. What are you pointing at? What?
Who is this?
My speaker? I should have two other little ones up there somewhere. No, I don't think I ever put them out.
How old is that speaker?
I bought that when I was in Okinawa. It's a computer speaker. That's the subwoofer part, and then I got the tweeters. When I was in Okinawa, that's when computers and internet was just coming out really big. And so I had a fishing game that I would play online. And I would play with people in America.
You had a fishing
A fishing game. Yeah, I forgot
Why
what
did
it's
you
called.
use fish?
Huh?
Why did you use fish?
Well, because it was on the internet and I was in Okinawa. There wasn't a whole lot of fishing I could do.
Oh,
I could not bass fish.
Oh, I see.
And you had to pull your mouse. And pull it. And I always broke my line. Always broke it. That's a fake game. Never have I gotten a fish big enough to break a line. But y'all okay with the conditions and how we checked them? Okay, real important. Very, very, very important. It's not that difficult to do. Just remembering you have to do it all. That's the hard part. Formula for a confidence interval for 2. Okay, this is in words. It's still the same words and formula, right? It's still the statistic, plus or minus critical value and the standard error of the statistic. It's just going to change a little bit. Okay? It's going to change a little bit. The statistic is no longer going to be p hat because we're looking at the difference of 2 proportions. So instead of just a plain old p hat, it's just going to be p hat 1 minus p hat 2. The critical value is still going to be z, and then that standard error is no longer going to be p hat 1 minus p hat over n. It's going to be p hat 1 minus p hat 2. Sorry, p hat 1 minus p hat 1 over n plus p hat 2 1 minus p hat 2 over n. I'll pull it up here in just a second. But it's the same thing we did last chapter. Statistic will be p hat 1 minus p hat 2. It's not a p hat all by itself because we're looking at 2 different samples. And I want the difference between those 2 samples as shown right here. So p hat 1 minus p hat 2. The critical value is still z star or just z. I don't care if you put the star there or not. And then that standard error is that really big one. It's the entire square root of p hat 1, 1 minus p hat 1 over n1 plus p hat 2, 1 minus p hat 2 over n2. You really want to confuse all the other classes and math classes, and you start showing them that formula right there. And that's the reason why I don't get kids to sign up for stats, because they don't want any part of it. But you guys, recognizing all this stuff, it's not all that bad. It's the difference between 2 of these things. It's still a z-score, and it's the standard error between 2 of them, and then that becomes pretty bad, but it's still not all that bad. It just looks bad. You got all these hats and the 2s, and remember why we have to have hats here, right? We have to have hats because we do not know the population average or the population difference. So we're using samples or we're using statistics. And so because we're using statistics and not parameters, we have to use p hats. All right. Everybody okay? I think it goes right into an example. Oh, no, there it is. Same thing. We're good. Same thing. When the conditions are met, we can do this. That formula is on the formula sheet just to make sure we can follow that, right? Here's the formula in words. You have to know the statistic is p hat 1 minus p hat 2. You have to know that the critical value is z. And if you forget that the standard error of the statistic, you just go down to the next one and you'll see standard error of the sample statistic. And here's one sample and here's two samples. So it's right there on the formula sheet. If by some crazy chance you don't remember that part of it. This is what we used last chapter. The only difference between this one and this one is the hats. This one says sigma of p hat 1 minus p hat 2. This one just says S of p hat 1 minus p hat 2. Then there's a special circumstance right here. We don't mess with this one yet. Okay, don't mess with that one yet. That's next chapter. All right. Here we go. Oh, this is a randomized comparative experiment. That will change up one little item. Here we go. Very, very, very common question that you could easily see in May. One of these, you'll either see a one sample or a two sample, no question. Now, I don't know if it'd be proportions or means or anything else, but you very possibly you can see a question exactly like this. Here we go. Patients with lower back pain are often given non-steroidal anti-inflammatory drugs. Who cares? Like Noxy, who cares? Who help us ease the pain? Researchers wonder if taking Valium along with the negative would help effective to find out. They recruited 112 patients. There we go. There's a good number I need. With severe lower and back pain, randomly assign them into one of two treatments. Oh, this is starting to bring up the chapter 1 stuff. So we randomly assign them into one of the two treatments. Naproxen and Valium, or naproxen and a placebo. Ooh, starting to really bring up some old stuff. So this one of these groups is getting two things, and one of them's getting two things, but one of them's fake. Okay. After 1 week, 39 of the 57 subjects who took naproxen and Valium reported reduced lower back pain compared to with 43 of the 55 in the placebo group. So I'm going to stop right there and start at least writing some things down. Okay. I know that there were 112 patients. I don't know if that's that big of a deal. And then I know I had two groups, Noxine and Valium, and Noxine and a placebo. So I'm just going to call this one sub V and sub P, because that's the only difference between them. I know that N sub V had 57 patients, with P hat sub V being 39 out of 57. I know that N sub P had 55, and P hat sub P had 43 out of the 55. Okay, so now I got my good information here. It looks like I definitely have two different topics. It looks like I have proportions, one, because I'm in that chapter, but two, they either had pain or they didn't have pain. So it's categorical data. I think I got everything out of this stuff up here that I needed. Construct and interpret. That means I'm going to have to do the whole shebang. A 99% confidence interval. Uh-oh, losing my marker again. For the difference in proportion of patients like these who would report reduced lower back pain after taking N and V versus N and P. So that's my difference. I need P hat sub V minus P hat sub P. Here we go. I have 2 independent random samples. They were randomized, and they are independent because this group over here was different than this group over here. So I think we have 2 independent random samples. I'm perfectly fine with you abbreviating those things. Independent random samples. 57 in V group and 55 in P group. If this was a test, I might say that the V was the Valium or whatever and the P was a placebo group. But I think we're okay. I think I can kind of follow that along. All right? Go ahead, you're good. Now, here's the trick to this one. Once I find out if that person has pain or not, do I put them back into it? I don't think I do. I don't think I'm sampling with replacement. So I don't think I need to check the 10%. See the trick on that? AP will get you. If you check the 10% and you're not supposed to, they'll get you. If you don't check it and you're supposed to, they'll get you. So it's really important for you guys to recognize, am I with replacement or without replacement? It's hard for me to recognize it sometimes. More times than not, it's with replacement. More times than not, you're putting them back in. Let's see what they talk about right here. We don't have to check the 10% condition because the researchers did not sample patients without replacement from a larger population. It wasn't a really large population that they were selected from. It was fairly small, and once I selected that person, I didn't replace it. Fair enough? Now I need, so, and if you do that part, guys, you're really telling AP, hey, I know what the heck I'm doing. So no need to check 10%. And I think you're okay with that, but if you want to say, cause no replacement. Okay? And that's what it says. We do not have to check that because the researchers did not sample without replacement. Large counts. So we need to prove large counts for this group and large counts for this group. So we need to show n times p and n times 1 minus p and n times p and n times 1 minus p. Here's kind of what they did. They kind of bypassed the n times p because they already knew the successes. N times p is 39. And n times 1 minus p is just going to be 57 minus 39, which gives me 18. So if you already know the success, the number of successes and the number of failures, that's the same thing as n times p and n times 1 minus p. I hope you guys can kind of understand that. I don't care how, you just have to check it. You have to check it. So 39 and 18, and the other one is 43 and 12. I haven't got close. But they're all greater than or equal to 10. For now, again, guys, I would like for you to put, so the distribution is approximately normally distributed. I got to verify some information on that from this book. I don't know why they're not putting that. I mentioned that already. That's been a huge deal because I know that's on the rubric. Students must check and verify that the distribution is approximately normally distributed. And if they say normally distributed, they get docked. And if you don't say anything, you got docked. I'm very certain on that. Okay. Method. I forgot to tell you the method, right? 2 sample Z interval. And I don't care that you do P hat 1 or P1 minus P2. 2 samp Z int. So that's my method. I would have remembered that when I went to my calculator. 2 samp, I should say proportion. Okay, that's why they do that. 2 sample proportion Z interval. And now I'm gonna write the formula. In the formula, I'm just gonna write it with variables, p hat v minus p hat p plus or minus z square root p hat 1 minus p hat v in v. In v. Plus p hat p 1 minus p hat p in p. Now I'm going to plug in the values. Sorry guys if y'all are losing me on this. I don't think my camera goes all the way over here. What is 39 divided by 57? I can cheat. 0.84. 0.684 minus 0.728. I'm sorry. 782. 99%. So I need to look up 99% or which is 2.58. He said 576, whatever. And then we'll do 0.684, 0.316, 57, 0.782, 0.218, 55. You don't need to show that step. We'll just put this. Negative 312, positive 0.116. Let me stop you right there. Show you how we get this on our calculator, because our calculator is going to do all this work for us. So you go to your calculator, we clear this out, we go to stats, we go over to tests. And instead of a 1 prop z int, now we'll do a 2 prop z int. And that's when I'll say, oh yeah, I need to write my method. 2 prop z interval. Okay. That helps me remind me I need to write it. As blunt as I can be, AP doesn't care that you write this and this. They want you to write one of the two. I make you write both because hopefully in May you can at least write one of them. It says you name it by name or formula. Okay. 2 prop z int, hit enter. X1 was 39. N1 is 57. X2 is 43. N2 is 55. 99, calculate, there it is. It does the whole thing for you. It actually tells you P hat 1 and P hat 2. Everybody okay with that? So we've done the method, we've done the conditions, we've done the calculations. The most important thing we have to do is the conclusion. We are 99% confident that the true difference of proportions. We are 99% that the true difference, you can't just say the true proportions because it's not proportions, it's the difference. And you can't forget out the word true because we're for sure talking about the populations. Let's see how they wrote it. Let's go back to here. And let's present. Boom. There it is. We are 99% confident that the interval, so they put the interval first. I put it at the end. Captures P1 minus P2, the difference of true proportions of patients who would report reduced pain after taking Naproxen and Valium versus the naproxen and the placebo. Holy cow. Don't write too much, but make sure you write enough to get it in the context. I'll be honest with you guys, right? There's what? 60 of you guys, 60, 80, 70. You got about 70 AP Stat students. I don't read that very close. I look at you get close to some kind of a in context. Fair enough. The main thing I'm looking for is the word difference and the word true population proportion or true or the population proportion, something that you associated with the everybody. And the word proportion. The interval I already checked in the calculation. So I will check the interval in the calculations or in the conclusion. You do not have to really write it twice. The actual interval, which is the -3, 1, 2, and the 1, 1, 6, I'll either check that in the calculations or the conclusion, but I won't check them both. So you really only need to write that once. We are 99% confident that the true difference of proportions of those who took whatever, I already forgot, naproxen and Valium and naproxen and the placebo is somewhere between here and here. Everybody okay? Again, it's not that difficult to do one of these entire steps. It's difficult to remember everything. Where students will mess up is checking the 10% when they don't have to, or not checking it when they're supposed to. Forgetting to put the name or the formula. Believe it or not, getting the right or wrong interval is not the most common mistake. That's probably one of the least common mistakes. And truth be told, AP a lot of times doesn't even check the interval. They don't care if you get it right or wrong. If you get it right or wrong, it's just because you don't know how to work your calculator. And they're not testing that ability. They're testing your ability if you know what you're doing. I still got a couple things to talk about. Y'all okay? Is everybody good so far on that particular problem? Many students lose credit when defining parameters in an experiment by defining the samples rather than the true proportion. Many students refer back to the samples as opposed to tie this into the population. So be careful on that. Okay? Don't describe p hats, describe p's. All right, here's the big question. This is the one that's going to start separating the 5s and the 4s and the 3s and 2s and 1s. Based on this confidence interval, right here to right here, and truth be told, AP is going to say based on your confidence interval. Because if you get yours wrong, they want the answer to your confidence interval, if that follows what I'm saying. It's possible to miss the confidence interval and get this part right, even though it's not right to the rubric. Because you missed this, then you're going to miss this. Well, that's okay. They're not going to double ding you. So just make sure you remember that. What conclusion would you make about whether taking Valium along with the Niprin affects the pain relief and justify your answer? So here's this interval. It goes from a -0.3 to a +1 point. What very, 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 very special number is in between a negative and a positive? 0. So if you're 18 and they're 18, what's the difference between 18 and 18? 0. Do I think one of them's older than the other one? No, I know they're not. So here's what we're going to conclude. If 0 is in the interval, I'm going to have to think there is no difference. I have to think there is no difference. And it doesn't matter, guys, if it's -0.00001 to 6. You still think because 0's in it, I don't think there's a difference. Is it possible to get 0 out of it? Darn right. I can shrink that interval. How can we shrink that interval? Well, we can change my confidence level, or we can increase my sample size. And that's other things that they might ask you about. So here it goes right here. Because the interval includes 0, and that's what you need to talk about. Because 0 is in my interval, we don't have enough evidence to think that there's a big difference between the two. And again, we should put that in the context. So we don't have evidence to taking Valium along with naproxen affects pain relief for patients like these, because these were selected. Talk to me.
So if 0 is not included, then we do have convincing evidence.
Then we do have evidence to say that there is a difference.
Okay.
And not only do we have a difference of which one, if they're both negative, we think the second one is bigger. If they're both positive, we think the first one is bigger. Y'all kind of feel that? Or not feel that? Feel me on that? Y'all hear me on that? So if they're both negative, then you have to think that this one's bigger. If they're both positive, you have to think this one's bigger. But if 0's in there, we have to think there's no difference. Great question. I'm glad you brought that up, and I hope to bring that up next time too. If they're both positive, we have to think there is convincing evidence. And not only do we think there's convincing evidence, we can actually say which one we think is bigger. If they're both negative, we can say that there is a difference, and we can actually say which one is bigger. But if 0's in it, anywhere, if 0's in it, then we can't say that. Even though it's more heavy on the negative side here than the positive side. 0's in it. So we just can't say there's a difference. Even though it's a little lopsided to that side. Again, if you don't want 0 to be in it, adjust our confidence level, make it a 96% or maybe 90%, because that will make this number smaller and that will make my interval smaller. Or increase those sample sizes, and that will decrease my interval. And if it decreases it enough to not capture this positive number, now I can say that there is a difference. And that's how people show these things, that it does work. Look, it works. And all I did was just change one number. That's why you have to be leery about all the statistics that you hear and see. You can make them say what you want to. Y'all okay with that? Good? Questions? Never say you believe that the true proportion is 0. Don't say that it is 0, because we don't know that it is 0. We just think it's possible to be 0. So because 0 is in the interval, we have to think that there's not a difference. Don't say the difference is 0. We think there's no, don't say that. That's bad. I get you. I just showed you already the calculator can do the difference between this. The calculator only shows these to ease the calculations. It does not cut out any steps. Fair enough. All it does is allow me to go from here to here without doing anything. And that's perfectly acceptable for AP. In fact, I highly encourage it. You hard heads that want to punch all this stuff up in your calculator more times than not miss this, don't you? You punch it up in your calculator and it gives it to you. Let it do it. Again, I don't care, but sometimes it's fun. Hopefully you know the conditions. Hopefully you know how to calculate and interpret the difference. And I'm done. This is kind of my very, very short plan, just to let you guys know, with this 50-50 kind of going on. I feel, however, I think I'm doing the best I can with the situation we have, I think. If you think that there's something better I can do, please let me know. I'm done with chapter 8. I'm not going to test on chapter 8 next week. I'm not going to do that because I just don't see you guys enough to be able to do that. I want to see your faces so that you guys can ask questions face to face with me. Fair enough with that? So we're going to kind of just keep plugging along, but I am going to take maybe 2 days off. I won't say 2 days, but when I say 2 days, it's Monday and Wednesday for you guys, right? And then Friday's a virtual day, so I'm kind of deciding on what I'm going to do there. But I think I'm just going to kind of start into the next chapter. Because if I keep taking 2 days to do tests, one thing is you're learning a lesson on your own, and I don't like that idea. And then 2 is it's slowing me down a little bit, and I don't like that idea. Because I told you guys, my most important thing for me is to get the information to you. My second thing is for you to show me that you understand something. But getting the information to you is more important than you showing me what this is. And so if we just keep going off, and hopefully if one time all this stuff kind of starts going away, we can start seeing everybody, and then we can start doing some different things. But right now, that's just kind of my agenda as I'm thinking in my head, okay? So just because we're done with the chapter, don't think we're going to be ready to hop right into another test real quick, okay? You have something, Ellen?
It was just that learning, starting to learn a new unit the day before.
Yes,
the take test.
I know it, and that's messing, you guys are kind of really getting the wrong end of that deal per se. Even though, you kind of have the weekend afterwards to kind of do it, now it's just, you guys are kind of getting screwed on that deal, which I get. So that's another reason why, fair enough. And I was talking to some of the girls before the class started, I really like this a whole lot better than what we did in the spring. You can try to imagine me trying to teach this stuff in the spring, just completely virtual. I just don't feel the same as I do with the kids right here looking at me. I can see if you understand it or not. I can see the confusion look or the, oh yeah, this is not that bad or that kind of stuff. So anyway. So I think next week, I'm going to have some worksheets for you guys. I wish I had them today that way or I wish I saw you guys tomorrow, but I don't see anybody. It doesn't matter. But somehow or another, I'm going to get you guys some worksheets so we can practice those also. And then we're looking at starting into the next chapter sometime. Okay? The next chapter is hypotheses testing. Bless you. Which kind of goes a little bit hand in hand with this, but I want to make sure we understand that part for sure. Now, the next chapter after that one goes into means. And if you can do the proportions, we can do the means because they're very, 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 very similar. They follow almost the same steps. They do almost the same thing. A couple changes in between it. It's 10:15. So we got work rest of the class period, whatever you guys want to do. Let me stop a live thing. Let me make sure nobody has anything they want to say there. Nope, still Carson. There's still 4 of them. Or they're running it. I don't care. Either way.
I had it running the whole time, but I just turned it off.
I get it, guys. My poor son, I get so mad at him and about both because, their teachers run the Google Meet the entire 90 minutes. And I'm thinking, so you got counted absent today? Dad, I sat there and listened for an hour. I don't care. I said, listen, act like you're listening. I don't care. Play the video game while you're listening. I don't care. Fake it. But I couldn't imagine listening for that long on a video. I can't imagine you sitting in class for that long. I'm preparing you for college. The only difference is in college, like if this was college, I can just say, okay, I'm done, and y'all go. Whereas I can't really do that in high school. Anyway, I'm done. Stop. End.